The first evaluation metric we will be discussing is the Blue score, or the bilingual evaluation under study. As the name suggests, it was originally used to evaluate translation from one language to another. How do we calculate Blue score? Blue score is scored by calculating the unigram precision. The first step is to look at each word in the output sentence and assign it a score of 1 if it shows up in any of the reference sentences and score it 0 if it doesn't. Step 2 normalizes that count so that it's always between 0 and 1 by dividing the number of words that show up in one of the reference translation by the total number of words in the output sentence. Continuing with our previous example, the ground truth being a grey car on the road. S1, that is, a car on the road, will get a score of 5 out of 6. S1 refers to sentence 1. S2, or sentence 2, contains a grey car in front of the house on the road, will get a score of 6 out of 6 because all the necessary components are covered in this. We see that the ground truth was a grey car on the road. In the sentence, the first sentence, a car on the road, has only 5 words, 5 out of the 6 words, hence the score is 5 by 6. But if we look at the second sentence, a grey car, 3 words here, on the road, 6 words here. Notice how some extra elements, that is a description of where the car is, that is in front of the house. In front of the house is also mentioned here. But since all the necessary points are covered, it scores 6 out of 6. Now if we neglect this part of the car being in front of the house, if we have just the 6 words grey car on the road, this sentence will also score 6 out of 6. Sentence 3 has on car grey car road. This will also get a score of 6 out of 6. And the sentence 4, which is car 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 car, will also score 6 out of 6. But if we notice carefully, sentence 3 and sentence 4 are not exactly right. The sentence 4 has majority of the words correct, that is car, grey, on, the, and road are correct. But the ordering is wrong, and we've noticed that car occurs twice here, and there's no article. Uh, sorry. You notice that there's no article in sentence 3. And in sentence 4, we observe that the word car is repeated 6 times. Hence, it should be, the score should in fact be 1 out of 6 because only one of the word from the original ground truth is here, but since it's repeated 6 times, the score of 6 out of 6 is appearing. We should not be scoring sentence 3 and sentence 4 so highly. To penalize the last two scenarios, we use a combination of unigram, bigram, digram, trigram, and n-gram by multiplying them. Using n-grams helps us in capturing the ordering of a sentence to some extent. So in sentence 3 scenario, we also cap the number of times to count each word based on the highest number of times it appears in any reference sentence. So the word car in sentence 3 will be scored six times because its number of occurrence or frequency is 6. It helps us avoid unnecessary repetition of the words. Even in sentence 3, we can observe that the word car has been repeated twice here. Once, and this is the second time. This is the second time. The first time the word car appears, the second time the word car appears. In sentence 4, it appears 6 times. To avoid missing out on the details in our captions by encouraging them to be too short, the unigram, bigram, trigram, and engram helps us avoid missing out on details in our caption by using brevity penalty, which we will see later on. We do this by comparing it to the length of the reference sentence that is closest in length. Here we have a pseudocode or a function rather, in which we check if the length of the output is greater than the length of the shortest reference, and we score the brevity penalty as 1. If the output text is shorter, we score the brevity penalty as length of the output to the power of the length of the shortest reference minus 1. Exponent is an inbuilt function to find the exponential power. And blue score is the unigram precision multiplied by bigram precision multiplied by trigram and so on till n-gram precision multiplied by the brevity penalty. The problems with blue score. The problems are as such, it doesn't consider meaning. In reality, the words in a sentence contribute unequally to the meaning of a sentence. So if there is a particular sentence and there is another similar sentence, but if the wording is not similar as per the ground sentence, it shows an error in the matching. Or we can say that it showcases that the two sentences are not similar. This occurs majorly when we are using synonyms or similar words or words that mean the same thing but may not be necessarily the same words. We have an example here. Ground truth being I have a maroon car. Sentence 1 is I have a blue car. Sentence 2 is I have a red car. Sentence 3 is I have a maroon boat, not a car. Notice how notice how all these three sentences differ by just one word. The first two sentences have a different color, but the third sentence have as a different object altogether. But using the blue score, all these three sentences will have the same score. This should not be correct because the weightage of the error in sentence 1 and sentence 2 is the color, but the sentence 3 has the word boat, which changes the meaning of this sentence entirely. If we use this in a real world scenario, if I said that I saw a blue car at the signal today, or I saw a red car at the signal today instead of I saw a maroon car at the signal, it wouldn't make much of a difference. But if I say that I saw a maroon boat at the signal, that would mean something is wrong. We don't see boats on the roads, do we? Hence, it conveys the wrong information. The blue score doesn't directly consider the sentence structure. It can't capture the syntax. The order of the words doesn't contribute a lot to the score of a sentence, or in case of translation, the order of sentences. For example, if I'm trying to evaluate the translation of a chapter in a novel, and I swap the first and second halves of the translation, it will only affect the blue score to a small amount. But in fact, if in reality, if we switch the first and second halves, it makes a drastic difference. Meanwhile, the translation of the storyline will be completely distorted, which is only acceptable in Christopher Nolan's movies. The blue score doesn't handle morphologically rich languages. If you want to say I'm tall in French, which is je suis grand and je suis grande are both correct translations. For those who aren't aware of French, the first sentence is if a male person or a masculine person tells I am tall, and the second sentence refers when a girl tells that she is tall. But if we use the blue score on this, the only difference is the gender of the word grand. The first one being for masculine, the second word being for feminine. But blue score counts this as as different as being night and day. If a model predicts one while expecting the other blue, we'll just consider it as a mismatch. The next evaluation metric is the squad, which stands for Stanford Question Answering Dataset. In this type of metric test, a question and a text are given, and the model needs to predict the answer from the given text. In case you aren't familiar with the fantasy reference, here is all you need to know to understand my knowledge of Harry Potter. Harry Potter is basically a book series by J.K. Rowling. Percy Jackson and the Olympians is entirely different and unrelated series of books by Rick Riordan. In the Harry Potter series, the protagonist Harry Potter is either in trouble or is on the way of getting into one, for likely 90% of the times. Percy Jackson is the protagonist of the other book series which I mentioned earlier, and this also shares a similar tendency of getting into trouble, just like with Harry Potter. There's a character named Percy, which is not very important right now, or it's non-existent in the Harry Potter series. That's all that's required for now. If I give you a text from Harry Potter series and ask you why did Percy Jackson and his friends fall in trouble, a human would be able to tell that this question and text aren't contextually related because it belongs to two different sets, right? The set of Harry Potter books and the set of Percy Jackson books. And hence it's not answerable. A Potterhead would directly disown me here, but when asked to an NLP model, it might just try to predict the most probable answer, which could be about some other character getting in trouble. If let's consider that Harry Potter and Percy Jackson had a character with the same name. Now, this character, if the question was asked, why did this character? Let's name the character something simple. Character X. Let's keep this character X. Now, if character X gets into trouble in the series Harry Potter, and we ask the question, why did character X get into trouble in Percy Jackson? The NLP model matches the most, that is, character X getting into trouble, and shows the result of Harry Potter or the character X being in trouble in the Harry Potter series rather than the Percy Jackson series. To address these weaknesses, Squad 2.0 combined the existing squad data with 50,000 unanswerable questions written adversely by crowd workers to look similar to answerable ones. Crowd workers are basically um, similar to something like a survey, or you ask the general people to help you out with the project, and hence we asked for questions etc from general public. To do well on Squad 2.0, systems must not only answer questions when possible, but also determine when no answer is supported by the paragraph and abstain from answering it. Now, if we have a question such as when will World War III break out? By the basic standard model of machine learning, the prediction would be made such that World War One took place in between 1914 to 1918, and then about 22 years later, in the 1940s, World War Two took place. But and through this model of prediction, the model might predict that World War Three took place in the year 1960s. But this should not happen, and it should consider this as an unanswerable question. The next evaluation metric is the MS macro, or machine reading comprehension dataset. It is a large scale dataset focused on machine reading comprehension. It consists of the following tasks: question answering, generating a well formed answer if possible based on the context passages that can be understood with the question and the passage context, passage ranking, that is, ranking a set of retrieved passages based on a given question, key phrase extraction, prediction, that is, the prediction if a question is answerable given a set of context passages, and extract and synthesize the answer as a human would. The dataset started off focusing on question and answers but has since then evolved to focus on any problems related to search.